Hello friends, welcome to my channel Study Corner. So today we will discuss about the motion in straight line. For everything in the world, the motion is common. Walking, running, cycling, blood circulation in our body, flowing of water, flying of birds, etc., which is considered in the motion. What do you think of when you hear the word motion? When any object, suppose this is an object, when any object changes its position with respect to another object, then we say that the object is in motion. There are mainly three types of the motion: motion in one dimension, motion in two dimension, motion in three dimension. Here is some example of a motion: periodic motion, rotational motion, linear motion, and circular motion. So, how can we know that the object is at a rest or in a motion? For this, consider the figure. Here, the frame of reference. Whenever we discuss on the motion, any reference point is important term. Now, suppose a bag is lying in a train moving with a constant speed. Suppose a bag is lying in a train which moves with a constant speed. Suppose the bag is this, which is moving with a constant speed. A passenger in the train would find the bag is stationary, but a person standing by the roadside would find the bag in motion. Thus, the bag is at a rest if observed from the train. It is in the motion if it is observed from the roadside. So, do you understand what I mean? Similarly, if we observe trees from the ground, they are stationary. From the train, they will be found in the motion. So, the motion is a relative concept. So, what is frame of reference? A place and a situation from where an observer takes his observation is called the frame of reference. There are mainly two types of reference of frame. One is inertial reference frame and other is non-inertial reference frame. Position, path length and displacement. To describe the motion of a particle, its position at every instant of a time must be known. To locate the position of a particle, we need a frame of reference. There is no any rules or restrictions on the choice of frame of reference. Position of a particle in frame of reference. Here, consider the figure. We can choose a three mutually perpendicular axes and then name them x, y and z coordinate. For example, here is the three axes, which is x, y and z. Point of intersection of these three axes is called the origin, O. Here, the point of intersection of these three axes is called the origin and serves as a reference point. The coordinate x, y and z of a particle describe the position of the object. For example, suppose our object is here. Then this x-axis, y-axis and z-axis tells that our object is here and says this position of a particle with respect to the frame of reference or coordinate system. So, suppose the position coordinate of a particle in motion at a time t1 is x1, y1 and z1, and at a t2 time is x2, y2 and z2. This shows the position of a particle with respect to the given frame of reference. So this is the basic concept. Of position. Now consider this figure: x-axis, y-axis and z-axis. So if all the three coordinates here this is x-axis, y-axis and z-axis. If all the three coordinates, suppose this is a particle which has x, y and z coordinate. So if all the three coordinates of a particle remains unchanged, which is not changing with time, the particle is considered at a rest with respect to the time and this frame. Now if one or more coordinates, suppose x, y and z, if one or more coordinate of a particle changes with time, the motion of a particle is called one-dimensional or linear motion. In first case, it is considered at a rest. In first case, if all three coordinates of a particle remains unchanged, then it is considered at a rest. And if all three coordinates, any one or more coordinates of a particle changes with time, the motion of a particle is called the one-dimensional motion or linear motion. So the example is object falling from the top of the tower. Suppose you throw a ball from the top of the tower, then the motion is a linear or one-dimensional motion, and motion of a car along a straight line. And there are so many examples of a linear or one-dimensional motion. Now let's discuss about the path length and displacement. So what is path length and what is displacement? Path length: the total distance traveled by the particle in some time interval is called the path length or total distance. For example, suppose you travel from point A to point B, then the total distance traveled by you in some time interval is called the path length or total distance. Again, the total distance traveled by the particle in some time interval is called the path length or total distance. And what is displacement? The change in the position of a particle. Change in position from here to here. If particle is traveled from A to B, then the change in position, there is change in position of a particle in some time interval is called the displacement. Let's take an example. Suppose the student travel from home to school. Suppose the student travel from home to school, and after the school he come at a point C. Here is point C and rest there. Then let's see the path length and displacement. Again, the question is, a student travels from home to school and after the school he come at point C and rest there, then what is the displacement and path length? First of all, the path length. Path length is OD plus DC. The student is travel from home to school, then OD, and from school to at point C, then it is DC. Therefore, the distance is in kilometers. Therefore, the path length is 4 kilometer. First of all, 4 kilometer. And the other one is 1 kilometer. From school to at point C, it is 1 kilometer. So, the total distance travelled is 5 kilometer. Therefore, the path length is 5 kilometer. And the displacement. Here, the equation, the displacement is equals to the final position minus initial position. Here, student travels from home to school and school to point C. Therefore, the displacement is point C minus point O. Therefore, the displacement is 3 kilometer minus 0 kilometer. Therefore, the total displacement is 3 kilometer. Therefore, the total displacement is 3 kilometer. Let's see the position time graph. Here A, B, C and D are 4 cases. Consider the case number A. In case A, the object is at a rest. The graph is about position versus time. On x-axis, we can take a time, and on y-axis, we take the position x. In first case, the object is at a rest and slope of a graph is 0. There is no any slope, and we can say that the velocity is also 0. In second case, if object is moving along a straight line, covers a equal distance in an equal interval. Here the motion is like that, and then it covers equal distance in an equal interval. Say this is time t and this is position. Further, at here it covers this distance. So we can say that the object is moving along a straight line, covers equal distance in an equal interval of a time, then it is called the uniform motion. In case C, if slope is a negative, here the slope is negative, then the value moving in a negative x direction. If slope is negative, object has a negative value moving in a negative x direction. In case D, if x versus t graph is a curve, here x versus t graph is a curve, it is said to be a non-uniform motion. This type of motion is considered as a non-uniform motion. So here are some important points. The path length is always positive. Path length is always positive, while the displacement can be positive, negative and 0. The displacement can be positive, negative and 0. The displacement has both magnitude and direction. Displacement has the magnitude and direction. Therefore, the displacement is a vector quantity. Thanks for the watching.